All right, good morning, guys. And people visit during office hours, and I see more problem of the homework assignments, and that will improve my teaching. So thank you for coming and asking questions. So for example, I think that's homework 1. I goes that direction, so electrons goes the other way, right? Let's don't talk about voltage for now because it's asking the energy of the electron. If you draw an electric field like that, plus minus, so when the electron starts moving, so where is the force? Where's the force applying? What's the direction of the force applied to the electron? That way, right? So force equals what? So if you have a source charge, and there's a little testing charge in physics, so there's a certain distance, so force equals what? It's okay, I couldn't remember that as well. So Q is the charge of the source charge over D square. So if you got a larger D, you got a smaller force, right? Anyway, so the force applies to the electrons is going to move the electrons towards the source charge because it's positive. It's attracting the electron to it. So what's going to happen is the force is applying to the electrons and moving the electrons to the anode so the electric field is going that way inside the component. So the electron is going to move that way. Look at the arrow, it's moving to the right. So there the force applies to it. It's going to accelerate, right? So it's going to speed up and getting faster and faster. When it reaches over here, it will slow down a little bit. But the thing is, there are two different types of. I just searched on Google. I never deal with all this like physics stuff of the electrons, like electrical engineer. Anyway, so there are two different energies. One is the potential energy. Another one is kinetic energy. If it accelerates, the kinetic energy will go up, right? So when it goes right, it's actually gaining kinetic energy by consuming potential energy. You do have a potential, so the electron does have a potential here, higher potential. So when it goes towards the anode, it's losing potential energy, but however, it's gaining kinetic energy. It's going faster by consuming potential energy. So the question over here is, definitely this question was developed by an electrical engineer. It didn't even ask what kind of energies is losing or gaining. It's just asking, is the electron gaining or losing energy? It depends which type of energy you are talking about, right? So I think since the solution is losing energy, so it's actually losing what energy? Losing potential energy. So let's assume it's losing potential energy. Okay, don't dig too deep into this. Just check lose. Okay, lose potential energy. That's it. Let's see if we have any other questions for tutorial 1. For that one of the problems, so to get the linear equation for the current, so this is 15, this is 20, this is IT, this is T, and this 20, 30, high school algebra. How do we get a linear equation for here and here? So for here, for T from 0 to 15, that's kiloseconds, whatever the unit is, right? So the equation is what? So the slope is 10 over 15, right? So it's going to be IT equals 10 over 15 t plus 30. What about the second one, which is 50? Oh yeah, that's right. So it's 15 and 20. So IT equals, so the slope here is 20 over 5. Oh, negative 20 over 5. And since we don't know the intersection here yet, so let's just plus b here for now, right? And then plug in the numbers to get b. So when y is 0, x is 20, right? So just plug in. What is b? Is that 80? Yeah, it's 80, right? So b is 80. So I got a second equation. And you find out that the voltage equation looks like this. Here's 20, here's 15, here's 10, here is 15. So it's just a one linear equation. Anything after 20 is not counted because you got a zero current. So power equals VI. When current is 0, power is 0. So we don't really worry about that at all, even though still have voltage. The voltage is a constant. It's a constant. However, current is 0, so power is 0. Don't worry about that. So what you are going to do is find a linear equation for here, okay? And use I times V in this time frame to get a power, plus I times V in this time frame to get the total energy, total power. Total energy, I'm sorry, if you integrate power over T, it's going to be total energy. So energy E equals like that, right? Just integrate it. Feel free to use the calculator. And also, to answer another question, I sent an email to the other teacher, other professors in the other sections, and calculators are allowed to be in the exam, but cannot be too advanced calculators. For example, I think you are allowed to program with the linear equations to solve, if you have different linear equations, you take the coefficients out to get a matrix and get an inverse matrix, things like that. I think that's allowed if your calculator can do that job. And you are in charge of developing your own equation cheat sheet, just one page, back and forth, whatever you want to put in there. That's another question. Yeah.
So is this first section mostly like electrophysics instead of circuits, and then after this unit it's more circuits?
I didn't get that question. Can I say it again?
So, like question 1 on the homework was more electrophysics based. Is the rest of the course going to be more circuits based?
No, it's because this class is 281, right?
Yeah.
So 281 has 3 sections. It's all the same for non-majors. And there's only one section for 282, which is the electrical engineers circuit 1 class with a lab. I think that's the difference. So there are about 300 students are taking 281 like you guys. You have another 200 students somewhere else doing the same thing. The same homework problems. Actually, it's very similar. Almost 90% of the problem the same for 282 as well. But they just, have a lab with it. Teaching materials are the same. Circuit 1 is all circuit 1. You couldn't make circuit 1 digital circuits. It's just circuit 1, basics. So we have almost the same expectations to you guys and also the electrical engineers. We're not reducing the materials to be taught in here.
Were you saying that equation sheet is allowed during our exam?
I think it's allowed during the exam, right? Is that what you usually do for physics and other things? That means the professor didn't say exactly for the exam, but I just asked him about cheat sheet and he said yes. So if you have a cheat sheet, why not using it for the exam? That's the point, right? I can double check with him and let you guys know. Did you do the same thing for physics usually?
This is kind of review for Phys 2 so far.
Yeah.
Yeah.
Okay, let me confirm with him one more time. Okay, for another one, I could tell a lot of our students are still getting confused regarding the polarity of the voltage and currents, because I have been having a few students visiting during office hours and asking the same question, basically. So if you see a device like this, and when I'm talking about the real physical voltage and currents flowing through the device, what does that mean? So there's just so many different situations. The currents going in, going out, voltages plus minus, minus plus, whatever way. Probably there will be 4 different situations. It could be difficult to memorize. And I never memorized any of these things since I understand what's going on. So what's the one simple rule that I can apply to all these cases? And then you'll be fine. So if you look at the table, here's the device, right? Plus minus V1. If I label plus minus, is that necessary that the voltage is dropping from here to here in real world, on the circuit? A positive drop from here to here, if I labeled plus minus, is there going to be definitely a positive voltage drop from here to here if I labeled it plus minus? No. Let me repeat the question. If you see on the diagram, there's a voltage labeled as plus minus. Are you always getting a positive voltage drop from plus to minus? No. Since that's what you have seen in the table, like V1, I1, there's a number 20, minus 20 volts, minus 10 volts. So if you just apply one rule to this type of problem, and you'll be fine for any other different situations. What's the rule here? Make everything positive, yes. So if you see a negative voltage, make it positive. So plus minus, there's the negative voltage drop from here to here. Because you see it, it's given. It's given. If it's a negative voltage, flip it. Flip the polarity here. Is that easy to do? If you see a negative sign, flip it. So it's going to be plus minus 20 volts. Okay? Just apply this one single rule to all different cases. If you see a negative current, here's the current labeled. If you see that, what you want to do? Flip it. So the current is going to flow out from the top, and you're getting 10 amps. Okay? So eventually you're having a device, have plus minus like that, and current flowing into it. Into what? Into the anode, or into the positive terminal. No, just anode. So now you can tell, this guy is absorbing or delivering power. Absorbing, since it's getting current flowing into it. It's like charging up the battery. Make sense? So eventually, what's power being absorbed? Just P. Absorb the power is positive, yes. So what's the power being absorbed? 20 volts times 10 amps, which is 200 watts. Is that clear? Any questions on anything? No? Cool. Let me grab another problem. 1, 2, 3, 4, 5, 6, 7 current labeled that way. So when you label it, you have to be careful about it, since here's a junction here. And if it's labeled on the left side of the junction, it has to be on the left side of the junction. You cannot move it a little bit to the right across the junction. That will be wrong, because that's just a branch current here. So it's asking you, so it's given I1 is what? I1 is 500 what milliamps. I2 is 0.75 amp. It's asking what is I4? What is I4? Apply which rule, which law here? KCL, right? KCL. What does KCL mean? Kirchhoff current law. Kirchhoff currents law, which is all the currents flowing into the node, if you add them together, is 0. Or you can say all the currents flowing into the node equals the current flowing out of the node, because you are not losing any current anywhere. It's like the pipe example I gave to you last time, right? Pipe. You got water current in two pipes, and here's a junction, and it merges into one main pipe. So the water current flows into here equals the water current flowing out from here. It's the same concept. So if you label this guy as a negative current that way, because I1, I2, I3 flowing that direction, they are equal. I1 plus I2 equals I3, right? So if you move I3 to the other side of the equation, you are getting I1 plus I2 minus I3 is 0. That's why KCL is valid, because minus I3, so I3 is flowing that way, so minus I3 is actually this flowing that way. Right? So this is equivalent to I1 plus I2 plus minus I3, which is 0. So that's how we verify KCL, because the currents flowing into the node equals 0, because one of them or several of them are flowing out. Okay? Flowing in equals flowing out. You flip it.
What's that next to node number 4?
Say again?
Is that I4 next to node number 4 in the middle?
Here? Yes.
Yeah.
Yeah, I4. Sorry. So the question is, what is I4, right? It's asking for I4. How? Yeah. I think as beginners, you guys are learning circuits just for 2 weeks, so you should know that for the branch, you're getting just one single current. It's just one pipe. So the current here is 500 milliamps, and current here will be 500 milliamps as well. So current here will be 500 milliamps. You agree with that from physics? Okay? So I2 is 0.75 amps. So what is this? Still the same current, same pipe. Same pipe. Is this flowing in or flowing out? Flowing out. This guy? In. I4? I4 is what? Flowing in or out? In. Okay? So what are the currents flowing in? Equals what? Equals this single thing flowing out. So plugging I1 and I4, I1 is 0.5 amps plus I4, which is 0.75 amps. So I4, you can calculate what that is, right? Okay? Any questions regarding this problem? Feel free to ask, because we will ask you helping others as well. It's been happening for the past few weeks. Any questions? No? Good on this?
What were given? What were the given values?
Oh, what are the given values? The given values are I1, I2.
I1, I2.
Yes. I1, so here's given, here's given.
I1 was 500.
500 milliamps, which is 0.5 amp. Is everyone good on this?
Can you explain how you separate the two different nodes? Like
Two different
how
nodes.
you got I1 and I4 on that side and I2 on the other side?
It's just one node here, right? Just one node. It's just one node, and the currents flowing into it equals the current flowing out. Okay, so this is going in, and which is I1 is given, and this is going in, but it's trying to it's not given. You are calculating this guy, and this is going out. So you have one variable and 3 currents in here. 2 is given, 1 is variable. You can calculate it using this equation. Is that clear? KCL.
This also technically requires you to know that current doesn't drop in series, right?
Current is what in series?
Does not drop.
Doesn't need to drop. Yeah, it doesn't drop. It's the same branch, same current. It's not dropping. Current is not dropping, right? It's yeah, it's a good question. It's an interesting question to think about, actually. Yeah. If the question is given, it's given. This is another thing. Like I was confused when I was undergraduate. You'll see this problem later, but if this thing is given in the circuit, one amp, 1 volt, 1K. Okay, this is given. This is given. You have to understand what's going on if this is given. It's telling you this is ideal. Let me write it down. Ideal current source. And this is the ideal voltage source. Okay. So which means this one is going to determine the current in this branch. It's just one branch, right? Even though you got a ground, the ground is just a voltage reference. It's not flowing current into the ground, into here. Yeah, let's don't say that. It's confusing more people. But anyway, so it's flowing that way and going back. So it's just one branch. One branch, then one current. Same current for that branch. Okay? No matter what kind of resistance being put in there, if this is ideal current, we just have to choose to trust it. Whoever developed it. Okay?
So, like a battery, the positive end emits current, the negative end absorbs current.
Depending on other components in the circuit. If you're charging up the battery or have other higher voltage sources in the battery, it's going to dump current into the battery.
True.
So it's competing, right? So you have higher potential, higher pressure. It's going to.
So could you take 2 batteries and connect them?
Yes, that's.
No, and like have the positive end of one battery put current through, say, an LED and a resistor, and then put it into the negative end of a different battery.
Let's draw it. Good question. I mean, here's answering all the questions you have. I had the similar questions in the past. So let's see. You got a battery here. You got another battery here. So you are talking about connecting them like this, or
Yeah,
have
and then the,
have a resistor in the
a
middle,
resistor in the middle. Yeah.
and then what?
Will there be current?
Yes, for sure. Yeah, because
No, there's no loop on that.
oh, no loop, no current because it's not closed.
But doesn't the negative end, isn't it like there's a chemical reaction that's trying to, that wants to gain electrons? So why can't the positive end of the other battery provide the electrons? Or really it's backwards, but because the electrons go from negative to positive.
Could I say that there's no?
If you connected the second battery to just itself,
Let me see.
Well, yeah.
Like 1 volt, right? 1 volt. So if there's no loop, the chemical reaction happens inside the battery, but I don't believe it's gonna drive anything outside of the battery because it's not anything inside if you don't have a loop.
What if they were capacitors instead?
Capacitor inside, capacitor where? In where? In the middle?
Instead of batteries.
Oh, it's the same. So capacitors are just finite charge holders. But these guys, because capacitors doesn't have chemical reactions inside, it just holds up the charges like you dumped into it previously, and it's gonna discharge at a point if you close the circuit. For example, you got a resistor, right? And you have a switch. You close the switch, it's gonna discharge it and dissipate that energy to the
If I had two capacitors.
two capacitors.
One
Yeah.
In the same configuration, and they were already charged, would the two capacitors like equalize on the sides through the resistor, say?
I don't believe there will be current flow, which means won't be electron flows in there. Because there's no reference. There's no reference. So all the voltage differences are across the capacitor instead of comparing to here. So you are thinking about, hey, there's a lower potential, here's a higher potential, right?
Yeah.
So is there going? The thing is, the potential differences are relative. So the charges or potential electric field only happens over here across the capacitor, but not here. You need a reference to let it know that this is higher, this is lower. Otherwise, they don't even know which is higher, which is lower.
But if like a negative charge just means that there's electrons there, should electrons want to equalize? Isn't that how that works or something?
Because here's positive charges accumulated, and here's negative charges accumulated. So it's forming another, if you put them close enough, it's going to forming another cap in the middle. If you keep them long distance, let me see if I can get a better answer for you later, okay? But the answer is there won't be any current flow, which means no electron flow into this if you don't close the circuit. But let me find a way to explain that why that happens. Good question though. Another problem here. This is homework tutorial 2. Tutorial 2. I plus minus Vx is R1, R, V, determine R, so V is 2.1 volt, Vx is 0.7 volt, R1 is 6 ohms, I is minus 1.7 amps. So what is R? Given all these parameters. So what I was talking about over here is, I didn't finish that. So for one branch, if it's telling you it's 1 amp, what's the current flowing through the voltage source? 1 amp. All right? You have to trust it. It's going to deliver 1 amp everywhere in the branch. Could you remember that? It's going to apply to so many problems in the semester. If I tell you the voltage across the ideal voltage source is 1 volt, you just have to trust it. It's going to deliver 1 volt across it. As long as you are not directly shorting the two terminals, it's going to deliver 1 volt no matter what. Okay? You can have another higher potential to compete with this guy and dumping current into it, but it's not affecting the voltage across it. Okay? It's always, permanently, voltage across the two terminals will be 1 volt. Is that clear? Okay? Remember that. It's going to be 1 volt. So, 1 amp flows through this guy, right? So we are determining the current flows into the circuit. Look at the current source, and you know it's going to be 1 amp. Do you need to worry about this guy? You are thinking, hey, this guy is giving up higher potential. It's going to push it back. So it's gonna cancel out that current source. So the current will change. No, I told you you have to trust it. It's gonna deliver 1 amp from left to right, 1 amp. So what's the voltage drop? According to Ohm's law, like we talked about. Ohm's law, current through a resistor got a voltage drop, right? Ohm's law. Current through a resistor got a voltage drop. So what's the voltage drop? Maybe 1,000 volts. Right? So getting 1,000 volts. Could you determine the voltage across the current source easily? Can you tell? Can you tell the voltage across the, what's the voltage across the current source? It's another thing. No, you don't know, depending on different circuits. It tells you it's a current, it's an ideal current source. It only tells you it's the ideal current source, but nothing about the voltage across it. You just have to build that kind of model in your mind at the very beginning you're learning circuits. It's important. Just have to build that model for the future when you analyze circuits. Do you know the voltage across it? No. But after you close the circuit, all the other components are given. Can you calculate the voltage across it? Yes. How? So what's the voltage across it? And how to calculate it? I times R, but you've got this guy here as well. So it's going to change it a little bit, right? So now let me draw this circuit. 1K, 1 amp. What's the voltage across the current source? Why? Because here's a drop here. What's the drop? 1,000 volts. Same wire, same metal. So there's a trick that you can always use. So the metal, we are treating them as ideal conductors, right? So the length doesn't matter. Actually, in the real world, it matters. But we are just using them as a perfect conductors. So what that means, I got a wire here. If I heat it up and melt it, they can actually shrink to a node. Can be nothing. Can be just a metal piece, right? So the voltage here is the same as voltage here, same as voltage here, same as. So it's gonna be the same voltage as here, right? So you can directly shrink it and make it just one piece. So it's gonna come back to this node. So voltage drop from here to here. See, voltage drop from here to here will be the voltage drop from here to here to here to here. And same thing. So eventually you are getting the voltage drop across the two terminals of the current source. So what's the voltage drop across the current source? It's going to be 1,000 volts. However, if you add a ideal voltage source here, it changes the voltage across the current source. And what is that? What is the voltage drop across it after you add this guy here?
999.
Say again?
999.
So do you want to add them together or subtracting one from the other one? Add. Why? Same direction because it's plus minus. So how do you deal with that? See, here's 0 volts, right? Ground. Even though a lot of circuits in the problems, they don't have a ground pin, but you can always just assume a ground, usually at the left bottom corner of the circuit, or the cathode of the battery. Not always the case, but for this case, you can do it that way. It's easier to analyze, okay? So 0 volts here, from minus to plus, it's being boosted. It's being boosted by the chemical reaction of if it's a battery. It could be a voltage source, a benchtop voltage source. But anyway, let's just treat it as a battery. So it's going to boost the 0 volts by 1 volt. So what's the voltage here compared to ground? 0 boosted by 1, what's the voltage? 1. Okay? Same thing. 1 volt being boosted by what? Even though the drop is from left to right. So from right to left, it's going to be boosted, right? Left to right is dropped. Right to left will be boosted. Okay? So from minus to plus, 1 volt will be boosted by what? 1,000 volts. So eventually the voltage at this point will be 1,001 volt compared to where? Ground. Make sense? Okay. Now let's look at this example. Feel free to ground here if you want. It's asking for the value of R. How to calculate it? What's the first step you want to do? What's the voltage here? What is the voltage here? What's the voltage here? What's the voltage here? Because 0 volts is getting boosted by what? It's being boosted by 2.1 volts, so 0 plus 2.1 will be 2.1 volts compared to ground. What's the voltage here? Vx, right? Because Vx is a drop from here to here. And what's the voltage here? 0. It's the same metal piece. You melt it, you heat it up, melt it, shrink to one piece. Same potential, same node. So voltage drop from here to here is 0.7 volts, right? And this is 0 volts. It's ground is 0 volts. So what's the voltage here? 0.7 volts, yeah. So what's the voltage difference? What's the voltage difference between these two nodes? This 2.1 minus 0.7 will be the voltage drop across it, right? So what causes the drop? What causes the drop across the resistor?
It's a resistor.
No, there's the current flow through it, right? Like I said, you got current flow through the resistor, you got a drop. If you get a drop, there must be a current flow through it, which is Ohm's law, okay? Is there a drop? Yes. 2.1 to 0.7, there's a drop. So is there a current flow through it? Yes. Where to where? Left to right. It's dropping from left to right. And what's the current? 2.1 minus 0.7 over R, right? Flowing that way. If there's a little node here, it's flowing into the node, What's the current flowing into the node out from the right? Same branch, same current. What's the current? What is still missing to complete the equation of KCL? You need a current here, right? The node has 3 branches connect to the node. So know the current here, which is this guy, has a variable in it, which is asking to calculate, which is R. And this is given. Is this current given? From top to bottom, is this current given? Not given, but I can calculate it, right? It's going to be the voltage drop divided by the resistor, which is 6 ohms. So it's all given. 0.7 volts divided by 6 ohms, you can get current flows top to bottom. So for KCL, you'll have 2 currents flowing in and 1 going out. So eventually you are using 2.1 minus 0.7 divided by R, which is a variable here, plus another current going into it, which is negative 1.7 amps, equals the current flowing out, which is Vx over 6 ohms, which is 0.7 volts over 6 ohms. Could you calculate R? Yes. Am I going to calculate it? No. It's a homework assignment. Not going to calculate it for you guys, but you know how to do it, right? Any questions for this? Any questions for this? What's that?
So in the topmost node above R1, you have an arrow pointing in on both sides. Would the right loop, is that for voltage or amperage?
Which one? Here?
The arrows pointing into that one dot.
It's current.
That's current. And
Because
then
it's a current source.
Okay.
Current source is providing. And we are doing KCL. KCL is Kirchhoff's current law, right?
Okay.
So we are dealing with current. Dealing with current only. But how to calculate current?
V equals I.
Yeah, I equals V over R, right? So you have to use V's. You have to get the V's to get the currents. That's the goal. You use all the V's. That's why I have to calculate the V's here first to get a current, right? You got a V, got a current, and then use KCL. Oh, conductance. You just need to know it. Not too many calculations with conductance. I talked about that during the first week. Conductance is just I think it's G, right? G is just 1 over R. G is 1 over R. And the unit is Siemens. How to spell it? Siemens. So in that case, I equals what? If you use G in the equation, I equals V what? VG, right? Because G is 1 over R, so it's going to be like V over R. I think this is all you need to know to solve the problem. So that's tutorial 2, probably. Yeah, tutorial 2. All right, conductance. Any other problems? If the circuit is valid. Some questions regarding if the circuit is valid. Sometimes they draw the voltage source that way. You just need to know what that means. The longer bar is usually the anode, and here's the cathode. It's labeling I1, I2, that way. And V is 2.25 volts. I1 is 4 amps. I2 is not given. So what is I2? I2, can you calculate? Not calculate, even calculate. But what is I2? All the equations are spinning in your mind right now, like V equals IR, like power equals to something. Do you need the R even? No. Do you need to worry about it? No. It's a lot easier than you thought. Yeah, it's negative 4 amps. Right? Could it be a different value? If you want a circuit to be valid, it has to be negative 4 amps. Does this matter? No. Because the current source determines the branch current, like I said. A lot of times you over worried about the voltage source, impact of the voltage source to the circuit for the current. But however, like I said, you just have to trust it. You just have to trust it. It's the ideal current source. If it tells you it's running 4 amps, it just have to 4 amps. So whenever you are getting a current, if the problem tells you this is 4 amps and this is negative 2 amps, what's happening? The circuit is broken some way. So it's invalid. It's an invalid circuit. It's invalid. Just can't do it. No. What about voltages? What about voltages though? 1.5 volts, 2 volts. Same 2 nodes, same circuits. Can I have different voltages?
For like the right-hand side node on the negative, would it be 2 volts on the negative end and then 3.5 volts between the batteries?
Yeah, what's happening for this one is definitely I don't think it's in terms of like valid or not valid. It's just not a good circuit. The problem is it's like shorting your circuits with a 0.5 volts battery. You know what I mean? Because the equivalent circuits will be just a 0.5 volts and shorting positive to negative. Just keep dumping current into this guy, and because the internal resistance of the ideal voltage source is 0, it's super low resistance. Keep running a huge current through it until it drains this out. So eventually, it will burn the battery really quick and drain this battery really quick as well. So what about I have a resistor in the middle? Is this valid? Like 1K, for example, give a decent value. This is definitely valid. You can definitely hold 2 volts here. You can definitely hold 1.5 volts here, no problem, without any problems. And what's gonna happen? What's happening in the circuit? If you have a resistor in the middle and 2 different voltage sources, is charging up another one? Yes. Yes, there will be a current flow through it and causing a voltage drop, which is it's going to be 0.5 volts difference. You can directly use 2 minus 1.5 as a voltage drop. Or what else you can do? Just Ohm's law. What's the current? Current times the resistor, get a voltage drop as well. Okay? Questions?
You said that the internal resistance of an ideal voltage source is 0.
Yeah.
How does that translate to like practical voltage sources like batteries or power supplies?
Battery and power supplies. The power supply is also considered as a 0 internal resistance as well.
If you actually run, if you set the power supply to 1 volt and then you put a 1.5 volt battery going in the right direction.
Yes, it's going to go to the other. Yes. It's going to get the current in. If you don't have any resistance in the circuit.
In practice, is it going to come out to be pretty close to 0?
Pretty close to 0 for what? To
For
0.
the internal resistance, like if you
It is, yes. So voltage sources have an internal resistance to be very close to 0, always. That's what we do. That's how they are getting designed. You know why? Because they want to deliver the voltage to the outside world instead of dropping internally. Two more minutes, okay? If you have an internal resistor and we can model it, we can take it out. This is, for example, our source. So if you take it out, because this is in series, right? You take the internal resistance out, you just model it that way. And so this guy has a 0 resistance, even though it should be, but just in real world, it's not. So we take RS out, this is really low, like 1 ohms, okay? And when you deliver voltage to the outside world, I have 2 volts. I want to drop the 2 volts to here, to the load. I don't want to drop anything here. So how do we want to drop most of the voltage to the outside world instead of itself?
Okay,
So V drop equals what? I times R, right? This is drop of the source, voltage drop of the source. If you want the voltage source drops the minimum amount of voltage, what do we want to do? What do we want to design the voltage source to be?
Low current, low resistance.
You are not controlling, low internal resistance, RS. Just make this low. You cannot control current. The current is determined by the outside circuit, right? So you have to make the RS super tiny, so it's not dropping any voltage by itself. It makes sense, right? You are supplying voltage, but you are dropping everything by itself, internally. You don't want to do that. You want to drop all the voltage outside, so you are supplying voltage to the outside world instead of internally. So make RS tiny will be the goal of any voltage supplies, right? Make sense? Okay. See you guys on Wednesday.